What if extinct animals could be brought back to life? Imagine a world where creatures from the distant past once again walked, soared, and swam alongside us. The concept of bringing extinct animals back to life, scientifically known as de-extinction, captures our imagination, blending science, ethics, and wonder into a spellbinding story. As we explore what would happen if extinct animals could be resurrected, let's journey through the science behind de-extinction, examine which species might return, and unravel the far-reaching impacts, ecological, social, and moral, of such an extraordinary development. Let us first step back and understand what extinction means. Across Earth's history, extinction has been a constant force. The vast majority of species that have ever existed, over 99%, are now gone, lost to time through natural disasters, changing climates, shifting continents, and more recently, by the hand of human activity. The dodo bird, the woolly mammoth, the saber-toothed cat, the passenger pigeon. These names evoke a sense of loss and curiosity. Over centuries, scientists and naturalists have carefully pieced together their stories by studying fossils, preserved remains, and ancient DNA. But what if those stories weren't closed chapters? What if technology offered us a chance to rewrite the tale, to actually reverse extinction? The science of bringing back extinct animals combines advances from multiple disciplines: genetics, cloning, selective breeding, and synthetic biology. The idea goes beyond science fiction. Dedicated labs are already pursuing de-extinction projects. Three main approaches lead the way: backbreeding, cloning, and genome editing. Backbreeding relies on the selective breeding of living descendants or close relatives of extinct species to recreate as many ancestral traits as possible. For example, scientists have attempted to bring back the aurochs, a massive wild ancestor of modern cattle, by breeding cattle with characteristics reminiscent of the extinct animal. While backbreeding cannot produce a perfect genetic replica, it can revive a creature with many physical and behavioral similarities. Cloning is the technique that captured the world's attention when Dolly the sheep, the first cloned mammal, was born in '96. Cloning involves taking the DNA from a preserved specimen of an extinct species and inserting it into the egg cell of a related living species. The cell begins to divide, and, if successful, it grows into a living animal. Cloning does, however, face serious hurdles, such as finding viable DNA, overcoming developmental obstacles, and addressing the lack of suitable surrogate mothers for ancient species. The most sophisticated method is genome editing. Tools like CRISPR-Cas9 allow scientists to make precise changes in the genetic code of living animals, editing them to include genes found in extinct species. For instance, to bring back the woolly mammoth, researchers are inserting mammoth genes into the DNA of Asian elephants, their closest living cousins, to produce animals adapted for cold climates. But the scientific obstacles only scratch the surface. If we could suddenly bring extinct animals back to life, what would the world look like? Let's start with the most famous candidate, the woolly mammoth. Trudging through the icy tundra of the Pleistocene epoch, these majestic giants disappeared from the Earth around 4,000 years ago, likely due to a combination of climate warming and overhunting by humans. If megafauna like mammoths could return, vast regions of Siberia, Canada, and Alaska, now covered by mossy tundra, might once again echo with the trumpeting of herds. One ambitious project, known as Pleistocene Park, proposes rewilding landscapes with resurrected large grazers, not just for curiosity's sake, but to potentially help restore ancient grasslands and slow permafrost melt, which in turn could help combat climate change by locking away greenhouse gases. Now imagine the skies over North America darkening once more with clouds of passenger pigeons, flocks so immense they were said to block out the sun for hours as they flew past. The passenger pigeon's extinction, caused by relentless hunting and habitat destruction, is considered one of the greatest tragedies of American wildlife. If we could bring them back, might they reclaim their ecological niche, dispersing seeds and helping regenerate forests? Or would the modern landscape, fragmented and urbanized, offer too little space for such numbers to thrive. Consider the thylacine, or Tasmanian tiger, the mysterious marsupial predator that once roamed Australia and Tasmania. Its ghostly stripes and dog-like jaws haunt old photographs and faded films. Hunted to extinction due to fears for livestock and competition, its absence left behind a vacuum in the food web. If thylacines were revived, could they once again help control invasive species and balance fragile island ecosystems? Or would they face the same pressures and misunderstandings that doomed them in the first place? Beyond these well-known candidates are countless other species lost from every continent. A parade of vanished birds, amphibians, plants, and insects. Their potential return sparks questions both hopeful and troubling. Could we mend damaged ecosystems, restore lost pollinators, or revive ancient interactions between species? Or would we risk unleashing new imbalances, new diseases, and unforeseen consequences? Bringing back extinct animals would not simply be a matter of achievement and spectacle. Each resurrection would be a complex ecological experiment. Ecosystems have evolved in the absence of these animals, often with new species filling their roles. Reintroducing a lost creature might disrupt current balances. If the woolly mammoth returned, how would it interact with today's forests and tundras? Would it help restore ancient environments or trample fragile habitats and compete with existing species? Passenger pigeons could seed forests, yes, but their overwhelming numbers might outcompete surviving bird species and spread modern agricultural diseases. Disease is an ever-present concern. Extinct animals might carry ancient viruses or bacteria susceptible neither to modern medicine nor the immune systems of current wildlife and humans. Or, lacking immunity themselves, they could be quickly wiped out by microbes their ancestors never encountered. With considerable gaps in ancient gene pools, these animals might also suffer from genetic weaknesses, leading to rapid declines despite our best efforts. And then comes the greatest question of all. Should we do it? De-extinction stirs a profound ethical debate. Advocates see it as a way to right the wrongs of the past, a moral responsibility to repair the damage humans have caused. For species driven extinct by hunting, habitat loss, or pollution, perhaps we owe them a return. Others see de-extinction as a dangerous distraction, sapping resources that would be better used to protect and restore the species already on the brink. Every dollar an hour spent on resurrecting the passenger pigeon is perhaps $1 an hour not spent saving the critically endangered ivory-billed woodpecker. Animal welfare adds another layer of complexity. Would a revived mammoth, raised by elephants but genetically different, belong in the wild or a fenced preserve? Would it suffer from the loneliness of being the only one of its kind, or from diseases for which it has no resistance? How can we balance scientific curiosity and ambition with our responsibility to the creatures themselves? At the intersection of science, ethics, and law lies the question of who decides and who benefits. If genetically engineered mammoths become tourist attractions, who owns them? Could revived species be patented, bred for profit, or even hunted? If indigenous communities once shared landscapes with these animals, should their perspectives shape the course of de-extinction projects? And what of the unpredictable ripple effects? Species that spread beyond their original ranges, hybridize with modern relatives, or unexpectedly dominate native ecosystems. The story does not end with animals. Some scientists are working to resurrect ancient plants, like the extinct silphium of North Africa, used as a valuable spice and medicine in ancient Rome, but lost for centuries. Imagine ancient grains and fruit trees, adapted for bygone climates, revived to diversify modern agriculture and improve food security. Could this offer resilience in a changing world? Or would these plants compete with native species for precious space? The technological challenges are immense. Ancient DNA is often damaged, fragmented by time and exposure to the elements. Even in the best cases, like permafrost-preserved mammoth bones or mummified passenger pigeons, getting enough intact DNA to reconstruct an entire genome is daunting. Cloning and gene editing come with risks of developmental problems, failures, and unintended mutations. For many extinct species, their closest living relatives are far removed. complicating efforts to use them as surrogates. Suppose we overcome all the hurdles and successfully restore a vibrant variety of lost animals to the world. How might their return transform our relationship with nature? On one hand, the awe of encountering living mammoths or watching flocks of once-vanished birds could inspire a new era of conservation and environmental stewardship. School children might read about the mistakes of the past not with despair, but with hope, witnesses to a world reborn through science. We might also see unexpected consequences. The existence of de-extinction technology could change humanity's view of extinction itself. If lost species can be resurrected, does it make us less cautious about driving others to the brink? Could the promise of a second chance weaken the resolve to protect endangered species, with people assuming that science can always repair the past? This tension is mirrored in other realms of biotechnology. The possibility of resurrecting extinct animals is, in part, a byproduct of the tools developed for human gene therapy, agricultural improvement, and synthetic biology. As our ability to read, rewrite, and recreate genetic material grows, so does our power and responsibility to determine what kinds of life belong on Earth. Cultural and philosophical questions are inescapable. Many societies hold spiritual or symbolic meanings for extinct animals. Some view their loss as a tragic break in the web of life. Others see their potential return as an act of hubris or a new chapter of creation. Reintroducing lost animals could revive traditions, restore pride in cultural history, and heal old wounds. Or, it could be seen as an unsettling blurring of boundaries between the natural and the artificial, the wild and the human-made. There is no single answer to whether we should bring extinct animals back to life. Advocates for de-extinction suggest strict guidelines, focus on species for which sufficient high-quality DNA exists, prioritize animals lost through human action, ensure that suitable habitat and ecological function can be restored, include the voices of local and indigenous communities, and commit to the long-term welfare of revived populations. Let us envision a world where de-extinction has been achieved. A century from now, perhaps, mammoth herds graze vast swards of steppe grasslands in the Arctic. Passenger pigeons flock through ancient forests, side by side with modern birds. Thylacines stalk the Australian twilight, elusive silhouettes among the eucalyptus. Prehistoric frogs and salamanders croak in rain-drenched pools. Featured in documentaries and protected in rewilded parks, revived animals spark a new era of wonder and respect for the diversity of life. Yet this is not a world divorced from challenge. The management of revived populations requires vigilance, monitoring their health, adaptation, and impact on their environments. Juggling old and new conservation priorities becomes the work of generations. Museums, universities, and governments build new ethical frameworks, policies, and laws, balancing the promise of reversal with a reverence for the natural course of history. In the end, the journey to de-extinction is also a mirror held up to our own species. It asks us to confront our legacy, both the destruction and the preservation we have wrought. It asks us to reflect on the values at the heart of our relationship with nature. Is life something we can recreate at will, or a trust to be respected and protected? Can we, through technology, atone for ancient wrongs, or does true stewardship begin by safeguarding what remains today? The story of de-extinction is still unfolding, written chapter by chapter in the labs and protected reserves of the world. Each step forward invites debate and reflection, caution and creativity. Beneath the science and spectacle lies a yearning, an ancient dream to rekindle vanished light, to hear once more the great and subtle voices lost from our planet's song. Whether or not we choose to bring extinct animals back to life, their memory shapes who we are and who we might become. In imagining their return, we are reminded of the incredible, irreplaceable tapestry of life and our solemn role as both its stewards and, perhaps, its storytellers. The biggest question may not be whether we can resurrect the lost, but whether we will learn to treasure the living world still within our care, before they too pass into memory. Thank you for watching the video. What do you think about today's topic? Feel free to share your thoughts in the comments below. If you enjoyed it, Don't forget to like and share the video to support the channel. Thanks again, and see you in the next video.